Let's go.
Hello everyone, you are welcome to my channel, and here is a continuation of the 2023 NECO Physics past question solution series. Here we are going to treat 26 to 30 objective questions. If you have been following us, we have done up to from question 1 down to 25. So today we are going to start from question 26. So question 26 says the wavelength of ultraviolet radiation is 6.0 times 10 raised to the power minus 7 meter. Calculate its frequency, given that c, the speed of light, is given to be 3 times 10 raised to the power 8 meter per second. So here, solution, given that the wavelength lambda is equal to 6.0 times 10 raised to the power minus 7 meter, and the c, the speed of light, is 3 times 10 raised to the power 8 meter per second. So we're looking for the frequency f. So remember our famous formula, v is equal to f lambda. So here v will be c equal to f lambda. So what is c? 3 times 10 raised to the power 8 is equal to f multiplied by wavelength, which is 6.0 times 10 raised to the power minus 7. So here you divide both sides by 6.0 times 10 raised to the power minus 7. Here 6.0 times 10 raised to the power minus 7. So this one we cancel this. So we have our f frequency equal to 3 times 10 raised to the power 8, everything divided by 6.0 times 10 raised to the power minus 7. So you press your calculator, 3 exponential 8 divided by 6 exponential minus 7. That should give us what? 5 times 10 raised to the power 14 hertz. So that is option C. That is option C, 5 times 10 raised to the power 14 hertz. I hope this is understood. So that's about question 26. So question 27 says, when the eye lens becomes inelastic and unable to accommodate, a person is said to be suffering from which of the following eye defect? A, astigmatism, B, glaucoma, C, hypermetropia, D, myopia, and E, presbyopia. So the correct option here is presbyopia. Are we together? So that is question 27. Question 28 says, which of the following statement is not correct about sound? Which is not correct about sound? A, musical notes are sound of regular frequency. Musical notes are sound of regular frequency. Yes, music produces regular frequency and it is pleasant to the ear. B, noise is sound of irregular frequency. Yes, that is why it is unpleasant sound. C, quality distinguished note of the same pitch. Yes, quality is one of the characteristics of sound wave. So it differentiates note of the same pitch. The one produced by, for instance, guitar is different from the one produced by violin. So it's the quality that distinguishes that. D, velocity of sound is dependent on atmospheric pressure. E, velocity of sound is dependent on temperature. So the correct answer is D. Velocity of sound has no dependency on the atmospheric pressure. It depends on the temperature, but it does not depend on atmospheric pressure. So the correct answer here is D. Question 29 is objective calculation. So it says a wire of length 60 cm is under a tension of 100 Newton. If its fundamental frequency is 300 Hz, calculate its mass per unit length. So this is under verification of the relationship between the length of wire, the tension with frequency. So here we have this relationship that the frequency is inversely proportional to the length, and is also directly proportional to the square root of tension of the wire, and same frequency is inversely proportional to the square root of the mass per unit length. So when you combine all these, you have the frequency is proportional to 1 all over length root of T all over mass per unit length. So F will be equal to K, by removing the constant of proportionality, K all over L root of T all over mass per unit length. So here, for a fundamental frequency, for the fundamental frequency or fundamental mode of the vibration, we take K to be equal to 1 all over 2. So when you put that, you have the fundamental frequency F naught will be equal to 1 over 2L root of T all over mass per unit length. So this is the formula we are going to use to solve this question. So here you are given that your fundamental frequency is 300 Hz, you put it, so equal to 1 all over 2 multiplied by the length. You are given the length to be 60 centimeter, convert it to meter, that will give us 0.6. Then square root of the tension is given to be 100, isn't it? The tension is given to be 100, then all over mass per unit length, that is what we are looking for, mass per unit length. Are we together? So from here, you can square both sides, find the square of both sides in order for us to remove the square root here. So first, let's simplify it further. That will be 1 all over 1.2, 1 over 1.2, then root of 100 all over mass per unit length. I hope we are together. So then square both sides. So here, square this and square the whole of this here. So if I do that, I'm going to have here to be 990,000. Are we together? Is equal to, remember this is going to be like 1 over 1.2 all squared multiplied by root of 100 all over mass per unit length all squared. So this one will cancel this one here. So we have 90,000 be equal to 1 square will be 1 all over 1.2 squared, which is 1.44, then multiplied by 100 all over mass per unit length. I hope we are following. So here I'm going to have 90,000 equal to 1 times 100, that will be 100 all over 1.44 times m, 1.44 m. I hope we are together. Then cross multiply. So I'm going to have 1.44 m multiplied by 90,000 equal to 100. Is that clear? So just say 1.44 multiplied by 90,000. That will give us 129,600 m equal to 100. So the next thing is to divide both sides by 129,600. 129,600. This one will cancel this one. So I have mass per unit length to be equal to 100 all over 129,000 rather 600. So mass per unit length will be equal to, that should be 0.000771 kilogram per meter. So convert it to standard form will be 7.7 times 10 raised to power minus 4 kilogram per meter. So let's look at the options. Let's look at the option. We have 7.72. Yes, approximately. If we had approximate, you're supposed to have 7.72. So the correct option here is option E. Option E. Are we together? So the correct option here is option E, 7.72 times 10 raised to the power minus 4 kilogram per meter. I hope this is understood. So that's about question 29. So question 30 says, how far from a cliff should a boy stand in order to hear the echo of his whistle 0.4 seconds later? Take the speed of sound in air to be 330 meters per second. So let's assuming the boy is standing here. Let's assume the boy is standing here and away from a cliff. Let's take this place for the cliff, or where the reflector rather. So if the boy clap, the sound will travel a certain distance x, and the echo will be heard back, right, after 0.4 seconds. So the total distance for the sound in air will be equal to, can call this one the distance, total distance d will be equal to 2x. Is that clear? So remember that the velocity is equal to the displacement or distance all over time. Is that clear? So what are we looking for here? We are looking for how far, that is the distance we are looking for. So here, the total distance here, this implies you're going to have 2x all over what? All over t. Are we clear? So 2x over t will be equal to the velocity. Is that clear? So from here, we can say make x subject of the formula. This implies you're going to have 2x will be equal to the velocity multiplied by what? Time, right? Which implies that x is equal to v times t all over 2, as simple as this. So the next thing is for you to just substitute the value. Let's manage this place. So x will now be equal to velocity is 330 multiplied by time, which is what? 0.4 all over 2. So when you say 330 multiplied by 0.4, that will give us 132 all over 2. So our distance x will be equal to what? It will be equal to 66 meter. When you say 132 divided by 2, that is 66 meter. I hope this is understood. It's very simple. Are we clear? So the correct answer here is option what? Option A, 66 meter. So we are going to stop here in today's class. In our next class, we continue from question 31. So I hope you enjoy the class. If this is your first time stopping by, please ensure you subscribe to give me some more visibility. Thank you. God bless you. See you in the next class.